Okay, so I'm like my screen is visible, right? Like to everyone, and I'm good to go.
Yes,
Okay,
go
cool.
for it.
Okay, thank you for this opportunity to speak here. And today I'll be talking about how to do a static code analysis for Terraform scripts. Normally, Terraform scripts are used nowadays a lot, like for infrastructure as code purpose, where we spin up the cloud infrastructure basically, maybe on AWS, GCP, or Azure. We do a lot of things using Terraform. So before I dive into, let me quickly introduce myself. I work as a practice lead for Azure and a principal architect for a healthcare organization. I have published 4 books, 3 with BPB and 1 with Appraise. And my expertise areas are like cloud, AI, robotics, and I'm TOGAF certified, Microsoft certified Azure architect. So that's a brief introduction on me, and let me move to the agenda. And today, I'm going to speak on these bullet points what you see here. Like I will give a brief introduction of what static code analysis is. Then we will see so what exactly or what it brings value to the Terraform world. So how we can leverage static code analysis in Terraform world, or rather like why we need it in the first place there. Then we will be diving into a lot of Terraform script tools, like static code analysis tools like TFLint, TFSec. Then the most popular Sonar Cube, because when we talk about static code analysis, we can't park Sonar Cube. But again, like you can, if you are aware of static code analysis using Terraform, you can definitely question me. Like Sonar Cube has very limited support, and they have started late in the game, and they have started building up now. So I'm talking about why like we want to discuss it here. So maybe like in the long run they will come up with a lot of capabilities, and they're building very fast the things, and roping in a lot of support, and coming up really fast in the Terraform area. So definitely we should take a look at the Sonar Cube, because they are the market leader, and soon like you'll find it everywhere. And then like if time permits, like I will talk about a DevOps pipeline example. So how exactly static code analysis, may it be Terraform, like or any static code analysis, how it fits in a DevOps pipeline. Because most of the times when we talk about infra creation or application deployment nowadays, so it's all to DevOps pipeline, and hardly we go and create anything manually. So let's get started with each of the agenda one by one. So what exactly is static code analysis? Static code analysis is all about like we build the code. As a developer, I build the code, then I debug, I review it, and analyze the code beforehand to figure out if there are any issues there, or like if there is something that a developer is mischecking, and I'm going to like face some kind of issues, or like maybe something like some organizations might have set some standards, like coding standards, like these are the coding standards, these are the naming conventions I need to follow. Or I should not be like maybe some security activities, like I should not be using 0.0.0.0 IP addresses, like in my while creating my cloud resources. Or like some kind of organizational rules that helps in making the code better or the code secure. So I can check using the static code analysis while during I'm building my code. Okay, so even before running it, like I'm writing the code, I can just run the tool and see like what are the different static code errors that I can figure out, and then I can take those errors and fix them and build a robust code that is more secure. And also like it makes sense to take it to the higher environments. So normally static code analysis helps you in debug, review, and analyze the code before the code executes. And as I already told you, it is done in the development phase, mostly by the developer. Okay, and even while during deployment to the target environments. Now normally we have different environments, right? First we build it and put it in the development environment, then we move to higher environments like test environment, UAT, prod. And for each of these environments, so like we analyze, we need to analyze the code again and again. You may ask me like, do we need to do a static code analysis in higher environment? So most of the time my answer is that we should be only doing it in the dev environment, because there we fix the code and build the binaries and create a release version of it. So once we are comfortable, then we carry it forward to the next environment. Then like if you are following this kind of an approach, you can ignore actually running the static code analysis in the higher environments. But if like at times you are like in the test environment, you may have a scenario like in the test environment, your tester comes in and they do a lot of testing, they find bugs and your codes are getting fixed in the background. In such scenarios, it is advisable to do those run the static code analysis even in the test environment, because wherever your code is getting impacted, there is a chance of code churn. And whenever like when code is changing, like there is a chance that you are deviating from the organization laid out principles or the code guidelines that has been set. So like whether you are on the dev environment or on the higher environment, it is advisable that you should be doing static code analysis across all the phases. So wherever you are having a code change. But if you're managing everything in the development environment, like in smaller organizations, I've seen that smaller customers, they do everything in the dev environment. The QA also test on the on a dev environment link, file the defects, fix, all fixing happens, and then it moves to the directly to the UAT environment. In such kind of a scenario, there is no code churn, so then you can ignore static code analysis in the higher environments. The lower environment you can get in. So in a nutshell, it is done in a development phase. And why we do it? Normally we try to figure out the quality and the security issues at the code level early in the game. And definitely it is done using automatic checks. We can do like even like can do a peer review, no doubt in that, but there are a lot of automatic checks available. There are a lot of good tools available that you can configure with the rule sets. You can also bring in your organization standards, rule sets, bake it in, and make it a part of that utility and run those checks. So this is how normally we try to like analyze like okay, before I get into the process, let me just talk about this. Why do we need to do it for Terraform? Okay, so here actually you see a script, a Terraform script here. I'll show it in the demo. Like we are going to get into each of the tools, we'll talk about each of the tools, I will demo you each of the tools and show you. But just at a high level, if you see here, there is nothing wrong in this. Okay, so I have my AMI defined, like, and I have an instance type defined. So it's a basically it's, and there are few other lines of code there, so I've just ignored it to keep it short in the deck. So like everything is fine, and it is as per the um, uh, like it follows all the standard definitions of the resource, and everything is fine. But when you do a Terraform apply, it will fail. Okay, Terraform validate will pass because there are no syntax errors. Okay, Terraform plan will pass, and even Terraform init, like it will initialize all the modules. So there you won't find any issues here basically in this resource. Okay, but there is an obvious error here. If you see here, it says that t1.2x very large. Okay, so this is not an instance type provided by AWS. Okay, it's an invalid instance type from AWS. Okay, so what will happen is when you do a Terraform apply, so like it will fail because it won't find a instance and it will fail upfront there. Okay, so like this approach will not help us in detecting the things early. So the developer will quickly code this. By mistake, he puts this 2x very large, which is an invalid instance type for your AWS EC2. So and next what will happen is he will do a init plan, validate everything will pass, and when he tries to apply and spin up the resources, it will fail. Okay, let me give you one more example where again like your Terraform scripts may have issues. Okay, one is like misconfigurations that we don't check here, we saw here, and another case is like your Terraform there are no obvious issues you see here, it is allowed. Okay, so but here if you see here, the source address prefix is 0000/0. That means it is allowing everything. Okay, it's a security issue, right? So like it's a challenge. And even if you do a init, plan, validate and apply, everything will work. Why? Because there is no syntax error. In the previous case, we had a runtime error here. Like this instance type is not a valid instance. That's why the Terraform apply failed. But in this case, there is no runtime error. Like everything is fine, and AWS accepts this. Okay, but it's a security issue. Okay, so none of these Terraform commands will be able to like detect it or warn you for that. Even Terraform validate, because it is allowed by the AWS uh, environment. Like AWS allows this to have this kind of a configuration, but your organizations will not allow this. They need to have a check over it. They don't want everyone to access your resources. Okay, your network should not be accessible to everyone. So this rule is an invalid or it's not a good rule to be defined. Okay, so you are allowing access to everyone, like 0000/0 means that only. Okay, so this is so here actually again we failed to validate the Terraform scripts. Okay, so then how I can fix them, or how I can detect them early, such kind of issues. Because here we see just a single block of code, but if you go to your production environments, you'll have thousands of files like this, and it's not possible for you to like check each of the files one by one and fix them. Like a lot of developers will be working in, and you can't review each of the developers code. So how I can do like get help for that? So you can use these tools like TFLint. So there are a lot of tools, but these are the standard tools that are used in the industry, like TFLint, TFSec, then Sonar Cube. So we'll see now like each of these tools in detail. So like what basically these tools in a high level do is, this is a tool like it's a static code analyzer. It can be as TFLint or TFSec or Sonar Cube, and rule sets are defined. There are a set of rules that are defined that does the check. Okay, even you can build your own rule set based on your organization requirement and plug it in to the code analyzer. Then you can pass the Terraform script to this code analyzer. This code analyzer, it will analyze the rules and it will give you the results. Okay, so that is how your entire flow works. Like whenever we are using any of these tools. And to be very open, like TFLint and TFSec are highly matured and they're heavily used. And Sonar Cube, though it's a very popular and widely adopted static code analysis utility, it's still catching up. But again, they're catching up very fast and they're building rules on the fly. Like I'm seeing at least Sonar Cube building rules every week, and every week there is a new rule that is being added uh, by Sonar Cube. So very soon it will like have a superb support for Terraform, and and most of the organizations, they use Sonar Cube, and so it won't be a challenge for them to like analyze the Terraform scripts, because Sonar Cube is already configured and they're already in the game. Okay, so let's start with TFLint. So basically TFLint, it supports plug and play architecture. So normally what you can do is you can bring in your own rule, and you can plug it. You can run the TFLint. It can pass. Even it has a good set support for the existing rule sets for the cloud resources. A very good support actually. You'll find a lot of rule sets for AWS, Azure, and GCP. So it easily highlights a lot of deprecated syntax, unused declarations, enforces best practices, and naming conventions. Okay, so let me take you to TFLint, and let's go through the demo. Okay, so this is the GitHub. It's an open source. Like you can also bring it down and play around with the code. So this is the GitHub link to TFLint, like Terraform-linters, then /TFLint. And here actually you can see like this is the way you can install, like for Windows, for example, you are using Windows, you need to install the chocolatey. chocolatey, like that is a package manager that you can use on Windows. So you can install that, and using the choco commands, like you get choco commands when you install chocolatey. You can do a choco install TFLint, or like if you're on Mac OS, then you need to use brew, or for Linux, this curl command will be good enough. Okay, so I have already installed it using the choco install, so I'm not getting into the installation part, and I'll just directly show you like few of the rules that are supported here. Then I will jump into the demo. Okay, so you can see like we have rules for AWS, Azure, and GCP. Okay, if you go to Azure, let me get into Azure, uh, and you can see how like I'll show you the steps on how to do it, but I'll just show you some of the rules here. There are 200 plus rules that are available. Like, see the number, like 200 plus. That means a good amount of rules are already there, and you can easily like use them. If you see here, like these are few of the basic rules. Then lot of these rules, a big list here actually. So like maybe like you can sometime you can get into this and you can see each of the rules. So I feel the rule set is exhaustive enough to check a lot of things, but there are few things this rule set misses. But again, using TFSec, we'll see later that we can catch up with. Okay, so now let me go to the demo. So I have already installed TFLint. So the very first thing that you need to do is, like, you need to create a file called as .tflint.hcl. It's a Hatswarp language file. Okay, so .tflint.hcl, and you need to say, like, normally, like your Terraform, like we normally, how do we do like any Terraform development? Suppose we are doing a virtual machine or a Azure app service. So how do we do it? Normally we install a plugin, right? So here also we need to do install a plugin for AWS, and we have this rule set. We need to pull this rule set down, TFLint rule set AWS. Okay, we need to pull this rule set. We need to install this rule set plugin, and we need to, then we can do the analysis. Okay, then I have a bunch of files, like here actually you see it's an invalid type. This t1.2x large is invalid. Okay, then I think, okay, then I have some more, like let me run the TFLint and show you the errors basically. So I'm inside this folder, okay, AWS folder, and it has a bunch of Terraform scripts. As a first step, what I need to do is I need to create this plugin. Once that is created, then you need to run this command TFLint init to pull that plugin. Okay, so already the plugin is pulled and it is installed. So I got this message, else it will pull and it will install it for you. Then you need to run Terraform, TFLint. Okay, then you need to run TFLint. What it is going to do is it will link to all of these files. Okay, see, it complained about this instance type t1.2x large is invalid. Okay, we saw it in this file. Okay, then it found these two errors basically. So in this file, so we can just get into just into the AWS. Okay, cd AWS, cd demo, cd AWS. Okay, now let me run the Terraform lint. So there is, I got one more error in this AWS 01.tf. The routing target is not specified. Okay, so these are basically like resource level errors. If you are working on AWS, you'll be able to spot it out. So I'm not getting deep into this, but just what I wanted to highlight is these are few of the obvious errors that the developers may miss, and that may or may not get deployed to your AWS environment. But like if you are running this TFLint static code analysis, you will be able to detect it beforehand. The similar way, let me run it for Azure. TFLint. Here also I got some error, like storage account type, I have not specified the storage account type. Okay, so it can give me a runtime error in AZ03TF, for example. The storage account type is not specified here. I have not provided it. Sorry, it's AWS script. In Azure, I will have AZ03. See, the storage account type is left blank, so it has complained about it. Okay, then Mac OS is not a valid type, so it's complaining about that. Okay, so OS type cannot be a Mac OS. Then it's complaining about this queue. Standard DS1v3 is an invalid queue. So it's in which file? AZ01TF. So Azure RM virtual Linux machine skill set, for this queue is not valid. So it's complaining about that. So it's not a syntax error, but rather like these are the errors that can occur at the runtime. Okay. So and also there can be some let me check if there are any security issues. Okay, we'll see, like when we are running the other tools, I'll show you on the way, like maybe in this set of files TFLint didn't detect any security issues, but let me run the tfsec. When I run the tfsec, we'll find some. Okay, now let me move forward and let's see tfsec. Okay, okay, let me move to the tfsec. Okay, so in case of tfsec, so like this is your, again, like it is also open source, and in case of tfsec, so like it's it checks for a lot of misconfigurations across all for a bunch of cloud providers. TFLint works for your Azure, AWS, and GCP, but still, like there are a lot of rules that are missing there, like that doesn't work with this TFLint. Okay, so like but if you are using tfsec, you get lot of more rules, like it is much more matured than tflint. So, and it is used heavily. I'll just show you, like the checks it has. So the tfsec sec helps you in checking AWS, Azure, GCP, CloudStack, DigitalOcean, then like, so many checks it gives you. Okay, so if I get into the AWS checks, okay, so these are the services it can check for, like EC2s. It has a wide range of support, you see, like it's much more than what you have in TFLint. For example, if I go to S3, so these all checks are there. So it's a pretty much of a broad set of rules that you get. Okay, and installing tfsec is also very easy. Like you also get a Visual Studio Code plugin. For TFLint, you don't have a VS Code plugin, but for tfsec you have a VS Code plugin. I'll just show it to you. So you can just go through this documentation and you can install it, like brew, or like for Windows you need to use Chocolatey, and you need to do a choco install tfsec to install it. Okay, for brew, or you can use Linux for brew, and so you get the command here directly, you can use it. But if you're using Windows, you need to install Chocolatey and do a choco install tfsec. I'm not getting into this Chocolatey installation and these commands. I've already installed it. So in this folder, I'm going to run tfsec. Okay, you see, like it has captured a lot more there. When I ran TFLint, I saw few errors, right? But here I can see, like I have got 6 errors: 1 critical, 2 medium, 3 low. Okay, so like one is like you can see, like Azure Azure App Service enabled HTTP2 is should be used, and it is using some outdated. I'm pretty sure like this issue has come in AZ04. Okay, AZ04 file, and I'm not using SSL, like app service does not have HTTP2 enabled. Okay, so again it's a low risk. It is categorized as low risk. We have another low app risk. App service does not have an identity type. Identity type is not defined. Okay, then there is one more result. So it is also low. App service doesn't have client certificates enabled. So like that, you when you analyze it, so you'll find a lot of rules out here like that has to be like fixed in the scripts. Okay, and this list is much exhaustible than what we had in TFLint, and more or less it points to a lot of security risks. It's figuring out a lot of security risks. It will also catch your those issues like instance type is wrong and all those things also this will catch. Okay, so in Visual Studio Code, you can install the let me show you this TFSec extension. Okay, when you install it, this TFSec extension, you get this. Okay, so this icon. So when you click on this, then and do click on run TFSec now, so it will run the TFSec for you and it will show you the results actually. Okay, no need of going and manually no need of manually running it actually. So you can also see the errors here listed down. When I ran this actually, from this extension, it populated me all the errors here actually, like the critical errors, high, medium, low. Maybe I have one critical error like in the network. The network should not be having any public ingress. I can go there directly and I see that again it's a public ingress I was talking about, right? 0000, like it should not be allowed. So it caught, but TFLint I'm not sure whether it caught or not. I think TFLint will also catch this, but we need to check. Okay, so but TFSec has definitely caught it and we have seen this. Okay, so that was the story about TFLint and TFLint and TFSec. Let us talk about the Sonar Cube. Okay, let me go directly to the Sonar Cube. And Sonar Cube supports a wide range of languages. I think around 40 plus languages. 30 plus definitely it supports. And it runs on a client server kind of an architecture. The server is your Sonar Cube server, like you install that. Okay, and on the client an agent runs and that keeps on scanning your that scans your code and posts the results. So for that I'll demo you that. Like I'm not getting into the depth of SonarQube, what it is and how it works, but let me show you how you can use SonarQube for Terraform scripts analysis. Okay, for installing SonarQube, like there are two ways. You can actually download it from the zip and you can do it. I'm using the community edition, so I'm not using the like your premium editions where actually you can purchase the licenses and set up a server and all. So I'm just running a community edition. So for the community edition, you can actually unzip it and run it, or like you can do it from the Docker image. Let me run it from the Docker image and show you the analysis. Okay, let me open a command prompt. So for the I need to pull the image from the Docker Hub. So let me go to the Docker Hub. I need to use this Docker pull Sonar Cube. So let me do this. So it will pull the default tag, the Docker image with default tag as latest. Just sometime it will take, like I should have pulled it and kept it handy. It takes a while, actually depends on the network speed, and it will pull that image basically locally. And once the pull is complete, then we can move to this next step, like where we can run this Docker command and start the SonarQube server. So by the way, it's pulling out any queries we have from the audience. Maybe I can utilize this time to clear the queries while it's pulling the image. Okay. Okay, the pull is complete. Now let me run the Docker. Okay, now I can open. You can see that I've started this on my 9000 port. I've exposed the 9000 port, and I can like access the SonarQube URL from that 9000 page. Okay. SonarQube is starting. So it's being served from the from this Docker actually. It has this server packed, and locally. So before I run the analysis, one more thing let me tell you. So what you need to do is, okay, while I'm setting the project, I'll show you like. So you need to have that. We have something called as a Sonar scanner CLI. Okay. So if you are doing the scanning manually, so you need to like use that Sonar scanner utility to do the scans. Okay. Now let me log into the Sonar Cube. It's for the first time the password is admin for this image, and it will prompt you to change your password. Okay. So now let me update this. Okay, I am in this. So I'm not going to run it from any of the pipelines. Okay, so I'm not going to select any of these options. I'm going to run it manually. So let me click manual. Let me call it as TFS, say Azure. Okay, as the project key. Then let me set it up. I want to run it locally. Let me click on this. Let me do a generate. I get this key that I need to use. So if you are running it on the pipelines, you must be creating a SonarQube setting file, a SonarQube file for your project, and you need to give this key there. But here, since I'm running it manually, so I just need to do this other. Select the windows for manually. Like you need to just install the scanner utility, the Sonar scanner utility. Okay, and once you have done it, so you just need to pass on this like key there. Okay, the key that we generated, the token file, and like scan it in the directory. Like just need to go to the directory, copy it, go to the directory. Okay, I think I created it for Azure, right? Just 1 minute. Azure. Let me go to the Azure directory. CD. Now I just copied this command. Okay, the Sonar scanner command. I've already installed this Sonar scanner. Okay, so I've followed this documentation on how to install it. I've set the environment variable, so I'm not doing it again. I've already done all those things, and I just copied this scanner. And now let me do a hit. Now it's doing a scan. Okay. So now I should be getting my errors here. Okay. So on the URL, I can see there are 12 security issues it has identified. Okay. So you can actually browse through each of these issues in each of the files, and you can actually, even low priority issues are there, like traceability, um, like all the static code issues. You can figure it out here actually. For example, uh, uh, omitting public network access enabled allows network access from the internet. Okay, that's a security risk. It has actually highlighted it for this script. Then you go to this client cert enables, says omitting client certificate enabled disables certificate based authentication. You won't, it's advisable to do a certificate based authentication. Okay, so you should not be doing this. Okay, so then you can fix it one by one. Okay, similarly, let me quickly, I know I'm just 3 minutes past. I'll just take 2 to 3 minutes more, and I will show you how to do it. Like I'll run this against the Azure thing also. So let me go to the projects. I'll create a new project manually. I'll call it as AWS. Set it up with run locally, generate, continue, same steps. Windows. Okay. Then I'll just copy this can. Okay. Then I'll go to cd AWS and I will run this. Okay, it's complete. Now let's see. See, we have caught one vulnerability and two security hotspots in the case of AWS. Okay, maybe you can again drill down and you can like see the issues, like change the code to disable support for older TLS versions. Okay, change the code to there is a older TLS version, TLS 1.10 is here, we should be using 2.0. So it has highlighted that in the script. So this is how we can use Sonar Cube for that. And just one last thing I would like to call out: Sonar Cube has a very minimal support at this point of time. Let me see. Maybe you can figure out in the Sonar Cube homepage. So it has very minimal support today, but that's not limited actually, basically. So very soon they'll be adding a lot of support. They're doing a lot of work in this area, and I'm pretty sure in the next coming months, we'll have a robust support for AWS, Azure, and GCP on this. So with this note, I'm done with my presentation.